which is support of the belief that garlic helps to fend off colds. What is the only problem with that? Basing a decision based on that. Sample size of 1. That's the only problem, and there's no problem with sample size of 1 except for the fact that you have to accept the margin of error that's so wide as to basically prove useless. So what do? Do a research study. You increase your sample size. You get a few hundred people if you can. You get as many as you can, and you get the margin of error knocked down. Beautiful. I like garlic because I'm Italian. But does that prove anything about colds?
No.
And I'm not even sure this study does, because if you check out what happened here, they said it was a double-blinded study. So I'm assuming what that means is they brought a bunch of people in. They gave people in white coats a bunch of pills that the people in the white coats didn't know what the pills had, but the people in the white coats behind the little mirror did. And then those people in the white coats gave them to the people that were in the study, and they didn't know either. So double-blinded means both blinded on both sides. The part that I'm a little concerned about is that they were allowed to go out and live their lives, and then they checked for the cold incidences after the end of the study.
They should have infected them.
They should have infected them.
Yeah.
Uniformly.
Absolutely.
Should have had them come back and
That
expose
would
them.
have actually
Yeah.
been a good study.
That actually would be a good study, because the problem with this is as soon as you let them go out of the lab, it's uncontrolled on a lot of variables.
Well, but if everybody, let's just say they're all average, I'm looking at this.
I'm hoping they are.
I mean, they're just an
I'm hoping they are for
I
first
mean,
statistics.
They're just people. They have kids, they don't have kids. It's just like an average.
You're mixing them all up.
65 out of 74 got cold.
Totally.
Versus
Totally.
24.
So you know this is going to be statistically significant.
Yeah.
Because more than half got colds without, and fewer than half didn't get colds with.
Not only more, like 3/4.
Exactly, a
Yeah.
huge chunk. Even with a margin of error, the margin of error would have to be ridiculously wide in order for this not to be significant. And we'll calculate that momentarily. But the question is, and I'm hoping you're right, Christina, we have to assume the averageness of the people in these populations. You have to make sure that they are average enough. Okay, sweet. How do we feed this into our machine to get a measure of significance? This is garlic and colds, right? Garlic and colds. How do we feed this into our machine? If you grab 2 sample t-tests, what do you put in there? What do you put in there?
So you'd want to do 2, right? You'd have to split them up.
What do we test? What variable are we testing?
What are
Gesundheit. Speaking of contextual, Gesundheit.
What are the garlic ones? 72, 24, 74, 65.
I want you to hear what Susie and Christina just said. Susie just said whether garlic works or not. What does that sound like? That sounds binomial to me. That sounds binomial. And binomial are what kind of random variables? Continuous or discrete? Are these guys measure discrete random variables? No, these guys measure continuous. That's the whole reason we have 2 different tests. When you have continuous data, you test averages. When you have discrete data, you test proportions. And Christina, you gave us the other idea as to why. Tell me what you said again.
I just took the total number, 72 versus 24, 74 versus 60.
Aha! So these were giving as out ofs, weren't they? You got 72 out of 146 and 74 out of, 24 out of 72 and 65 out of 74. That sounds like a percentage, doesn't it? It's written as a fraction, but it's a percentage. Friends, it's still 2 parameters. It's still 2 parameters because you're testing those who got the garlic and you're also testing those who didn't. So it's 2 independent groups, but you're not testing averages. I'm not talking about the average length of the cold or the average severity of the cold. I'm talking about did they get a cold or not. That becomes binomial, and that's this guy right here.
Or they took the garlic or not.
Exactly. But
Right.
that's the how's that called? The experimental condition. The result is whether they got a cold or not,
Right.
based on what they got. So this is our first example of a 2 proportions test versus a 2 means test. So all we've got to know is what to run then. And conveniently enough, it looks just like the one you ran back here, which was called 1 prop Z, except this one's called, predictably enough, 2 prop Z. So I'd still like to write the hypothesis out, because I'm with Lindsay. Totally. So we have 2 proportions now. We have 2. Back in the day, it was just 1. with P equals something, 0.75, 0.13, 0.25, whatever. What should we call? Who should be 1? Your guys' call.
Those that get the garlic.
Those are the garlic. So P1 is going to be the cold rate with garlic. Garlic. And there's an L in there. There's an I too. Good Lord. And P2 is the cold rate without. Cold rate without garlic. Our job, let's see if garlic is knocking colds down. Christina's got to vote for yes. It sure as hell looks like it is. And it sure as hell does look like it is. It does, because that fraction is so much higher than the other fraction. It's way past a half. The only concern I have is a relatively small sample size that might let the margin of error grow to the point where they overlap. That's the only problem I have. I'm not that concerned because I think it's going to be pretty significant, but I still think it's worth testing for significance, hence the whole idea of the hypothesis test. So, null says there is no difference at all. Research says yes. P1 versus P2 is going to, now careful with this one. What's the sign going to be on that one, P1, P2? And this is, I know we get hung up on signs.
That's not equal.
Well, not equal, just see if there's a difference. I think Christina has a vote that the garlic people are actually getting fewer colds.
You want to be greater.
So P1 is the cold rate with garlic. So what's that be less than?
Yeah.
Right, friends, rest, yes?
Yeah.
Because they're getting fewer colds, which means the chance of a cold is less. And that's what screws up 244 students 90% of the time. It's just making sure the sign's pointing in the right direction. Ashley's got a good solution for it. Ashley's solution is to hell with it. Test them all double-tailed. Double-tailed will send them into both tails every time. The only problem with that is it doesn't test to actually see if it's greater or less than. It just tests for differences. But there are some statisticians that only run two-tailed tests, just to look for significant differences, not necessarily for greater or less than. And we'll talk more about that in your homework set. Fair enough? Let's run it. I got to change the graphic too, because it isn't U1, U2 anymore. Now it's going to be P1, P2. The test statistic is almost identical. It's almost identical.
Janitors loves you.
Don't worry, we'll erase it later. It's almost identical. It's the same idea as a t-score, except now it's going to be, what do you think? Since we're testing proportions there, we're back to which distribution are we back to? We sure are. We're back to the z-score. So the bell curve will actually be a z curve versus a t curve. Look how simple this is, friends.
Was it number 6?
Yep, it is number 6. And look how simple this is. It's gorgeous. If you guys don't mind, with garlic, how many out of how many got colds? 24 out of, that was the 1/3. Good. And then without garlic? 65 out of? 74. Notice how the sample sizes aren't exactly equal. They probably started being equal, or at least within one of each other, and then somebody didn't bother showing back up for the follow-up study. I mean, that happens all the time. Non-response happens all the time. And look at that, there's no null hypothesis to fill in. Did you catch that on the last one either? There was no null hypothesis for the two-sample t-test either. And that's because they always assume the null hypothesis is this. There's no value to plug in because they always assume that they're equal. So there's nothing to put in there. Beautiful. All you got to do is make sure you get the sign right. And there's our sign right there. Sorry about the extra writing on the board. Fair enough? Let's do it. Much faster. Look at that. Look at that. So, any concerns I had about the margin of error being too wide are pretty much gone, because what does this tell us?
6 standard deviations.
We are 6 standard deviations away from them being equal from each other. I love that, actually. Well said, my friend. We're 6 standard deviations south of them being equal. So here are our cold rates. Here are cold rates. Actually, take that back. Time out. Here are differences in cold rates. Right? 0 would be in the middle. We coming down here. Garlic's working, garlic's really working. Look at the p-value. It rounds to 0. Rounds to 0. So there's definitely a humongous lowering of cold rates based on this, assuming this data is okay to trust, which I think we've raised a lot of questions as to why we might not want to. But assuming that the data was valid, this is good indication that garlic's actually keeping colds away. Plus, it's garlic. It's freaking awesome. Well, okay, then you listen to Robin Leach. Yeah, he said you use garlic tablets. Odorless. That's the wrong accent. He's more of a Cockney.
Yeah.
That's more of a Nigel from Spinal Tap. Sorry. Cool? Yes, you're far too young then. Don't worry. Who is Nigel? Who is Robin Leach? 2 people know. Two people in the room have seen Spinal Tap. Excellent. Excellent.
What did I do for Halloween?
You were not for Halloween?
You were in class.
Did I do that last year?
Yeah.
Oh my god, I bust that out every once in a while. I forgot I worked the class.
Yeah, it was
oh,
cool
that's
too.
freaking awesome. Yes. You were there. You must have been there, Ben, right? Had the hair down and the
Hedgehog in your
tight
pocket?
trousers. No. No, Rod. Forget I said anything. Let's do another. Let's do one more to make sure we can firm up the difference between these two. Right? So we've got placebo or monitoring the future. Your guys' call. Your guys' call. Same data set there. Placebo one. Placebo study. The one under garlic. Read. Go ahead and read that one. Knock out one more and we'll call it a day. It is pretty cool, actually. It's pretty surprising.
It's actually, a scientist that does nothing but test the placebo.
The idea of, yeah.
The fact that placebo is actually more evidence than that.
And that's why I've never seen this study replicated, so I'm glad somebody else is doing it
Oh, yeah.
to see, and it's just the power of mind over medicine.
He isn't focused out on that.
That's excellent. Yeah, this is the first study I've seen where it was actually, but the sample sizes are so small, I didn't see it replicated. Like I want to make sure that well, we'll go back to that too. There's definitely some experimental issues I want to talk about with this, but as far as experimental results, like